Good day. Welcome to EEG 211 lecture. I will quickly revise the topics covered in week 4, which are linearity, superposition, and source transformation. And this is shown in the outline. So to start with, what do we mean by linearity? Linearity, it's by definition should satisfy two conditions, which are homogeneity and superposition. And by homogeneity, it means that if you scale the input to a system by a constant, the output will be scaled by the same constant. And for example, these are shown below. If the inputs to a system, they are given by x1 to xn, and the output from that system is y1 to yn. Then if such systems satisfy homogeneity condition, then if you scale the input by a constant a, which is defined by ax1 to xn, then the output should be ay1 to ayn. Then such system satisfy homogeneity condition. What of superposition? Superposition, it's defined by if you have a first set of inputs, which is defined by xa1 to xan, and if a set of input is the first set is fed into a system and it gives you output ya1 to yan. And if you now have a different set of input, which is xb1 to xbn, if you feed in such input to the system, which will now give you yb1 to ybn, then if you now have a situation whereby you combine the two inputs together in form of xa1 plus xb1 up to xan plus xbn, then the output should be ya1 plus yb1 up to ya1 plus ybn. So what this tells us is that when we combine inputs into a system which satisfy superposition, the output, the resulting output will be a linear combination of the outputs when the individual inputs were applied alone. And in the light of this superposition principle, what do we mean by linear circuits or linear systems? We see that linearity or linear circuit, they are systems which generally they have linear elements. And by linear elements, we mean that the current is proportional to voltage in those elements. And linear circuit or linear system, they obey homogeneity and superposition rules. An example of linear elements, they are capacitors, inductor, and resistor. In capacitor, the current is proportional to the derivative of the voltage, whereas in inductor, the voltage is proportional to the time derivative of the current. Where in resistor, the current is proportional to voltage. All these elements, they are linear elements. And if you now have a circuit that contains all these elements, we say that such circuit is linear, or such system is linear. Now, the next question I would like to ask is, in the previous slide, we talked about inputs and outputs. So what are the inputs and what are the outputs of a linear circuit or linear system? If you pause a little bit and think about that, we will realize that the inputs to a linear circuit or system, they are the independent sources, the independent voltages, and the independent current. They are the input, whereas the outputs, they are the node voltages and branch current. Those are the outputs. So when we talk about input and output in a linear system, we refer to the input as the branch and node voltage that we are interested to calculate as the output, whereas the input is, they are the independent voltages and current. Please take note of this. Now, what does superposition principle says? Superposition principle says that in order to determine the total response due to all independent sources in a linear circuit, we can determine the response due to each source individually, and then summing them up to get the net response. So what that means is that when you have a certain number of independent sources in a linear circuit, and for example, you are now interested to determine the outputs, maybe the branch current or the node voltage in any part of the circuit due to all the independent sources. Superposition principle says that to determine the net response or the net output, we can simply determine the responses due to each individual circuit, due to each independent sources applied alone, and then combine the individual responses, combine the total individual responses due to all independent sources, will give us the net response. What's the procedure? The procedure in superposition, the first step is that we form a subcircuit for each independent source with all other independent sources set to 0, or typically we say with all other sources queued. And to make a comment by that, how do we kill an independent source? Shortly, I will describe that. Let me just say the step first. After forming the subcircuit for each independent source with all other independent sources set to 0, we obtain the response due to individual sources from each subcircuit. And the last step, we now obtain the total response by summing up the individual responses. This is a procedure. Now, what do we mean by killing an individual, killing an independent source? To kill a voltage source, we do not just simply remove it from the circuit. What we do is we apply a short circuit. We replace that voltage source by a short circuit. Remember, the voltage across a short circuit is 0, whereas the current can be infinite, can be anything, surely. Whereas to set a current source to 0, we apply an open circuit. So we replace that current source by an open terminal or open circuit. In superposition, please take note, dependent sources are left as they are in the circuit. You do not tamper with dependent sources. You only short circuit independent voltage source or open circuit independent current sources. Whereas dependent sources, they are left alone. Let's try to solve this example in this circuit. In this circuit, there are four independent sources, which they are minus 5 volt, 3 volts. They are independent voltage sources, whereas minus 1 amp and 2 amps, they are independent current sources. And the question is, can we determine the current flowing through the minus 5 volts independent source and the voltage across the minus 1 ohm independent current source? So how do we do that? So the first thing that we will do is that we will need to obtain Vx and Ix due to each of the sources acting alone. And that means that first we get contribution from all the four sources. So we will start with, let me go back a little bit, with the minus 5 volt independent source. That means we leave the minus 5 volt independent source alone and we set all other sources to 0. Remember, to set voltage sources to 0, you replace with a what? With a short circuit. And that is why the 2 volt voltage source here is replaced with a short circuit, whereas the current sources, they are replaced with open circuit. So the next thing is you now drop the sub-circuit. You draw the sub-circuit while you leave the source that you are interested in getting the response. And in this case, it's minus 5 volts. And then we now determine the response, Vx and Ix, due to minus 5 volts acting alone. And in this case, if you apply the principles of, or even by inspection, you will easily see that your Vx is the negative of minus 5 volts. Why? Because the Vx, the positive terminal of Vx is connected to the negative terminal of the minus 5 volt source. So that's why it is negative. And we still keep the minus 5 volt as it is because the question says we have here minus 5 volt. So, and if you, by inspection, you can easily see that Vx is 5 volt. Similarly, we can calculate the current Ix. The current Ix in this case is seen to be current flowing through the 2 ohm resistor. So, and in this case, it's just the voltage across the resistor divided by the resistance going by Ohm's law. And but if you do that, you get minus 2.5 amps. So secondly, we also determine the contribution from 3 volt source. And following the same principle, we leave only 3 volt source and set other sources to 0. Again, we draw the sub-circuits as shown below here. And when we do that, we see here that the 3 volt source here, it's alone. And whereas the other sources, they are set to 0. The voltage source by a short, current source by open. And also you solve for the responses, which are the branch current and the voltage Vx and Vx2, which are Rx2 and Vx2. And also by inspection, we can easily see that since here is an open circuit, the voltage Vx2 is just the voltage across the 3 volts independent voltage source. Why? Because no current is going to flow through the 2 ohm resistor and the 3 ohm resistor. So it is just redundant there. And Ix2 equals to 0. Why? Because the current flowing through this branch with the cursor is 0. And if you look at that, so it means that this Ix2 is just going to flow through the 3-volt source, and it goes through again this resistor and back into this terminal here. And since here is an open terminal, so no current is actually going to flow. Again, we determine the contribution from the -1 ohm source. So we follow the same principle. We leave the -1 ohm source. We remove or we set other sources to 0, other independent sources to 0. Again, we draw the subcircuit, and then we determine the response. And if you do that correctly, you will see that Vx3 is 3 volts and Ix3 is 1 ohm. And the last one, we determine the response due to 2 amps source. So that means we leave the 2 amp source alone and we set other sources to 0. Again, we draw the subcircuit and we calculate the response. And if you do that, we see that Vx4 is -6 volt and Ix4 is 0 amps. And then the last step is now to determine the total response. And in determining the total response, we just sum up the responses, all the 4 individual responses, which are Vx1, Vx2, Vx3, and Vx4. And if you do that, we see it to be 5 plus 3 plus 3 minus 6, which will give us 5 volts. And similarly, if we do the same for current, we sum up all the individual current responses, and this will give us minus 1.5 amps. And this is solved by superposition principle. Quickly before I leave, I will also discuss or remind you of a very powerful technique, which is source transformation. And what this technique says that for ideal independent sources, you can transform a voltage source with a series resistance. You can easily transform it into a current source in parallel with a resistance, using this relation where your current source will now be the Vs divided by R, where the resistance is just the same resistance that was in the series resistance will now be connected in parallel. And similarly, we can convert a current source in parallel with a resistor. We can convert it into a voltage source, independent voltage source in series with a resistor, which with this relation, what this tells us that it also means that we can simply convert a battery with or an ideal voltage source with internal resistance, or a battery with internal resistance, into a current source with a resistance in parallel to that current source, by following this relation. And we can also convert a current source with a parallel resistor into a voltage source with into a voltage source in series with the resistor using this relation Vs Is. So thank you for your attention.